Hello, I'm Bill Faulkner, and welcome to the last in our series of SMRT safety video podcasts for MR Safety Week 2017. In this last video podcast, we're going to look at managing SAR. And recall that we expose our patients to electromagnetic energy, an RF field, the B1 field. And this consists of two components. There's a magnetic field and an electric field. A component of the magnetic field is used to excite the protons and tip the net magnetization into the transverse plane so we can obtain an MR signal. The rest of this primarily just goes to tissue heating. Now, tissue heating in MR is a result from RF energy being absorbed during an MRI exam, and the heating is primarily caused by magnetic induction. The heating is greatest at the surface and then less toward the center of the body. The amount of RF energy absorbed into the body, into the tissue, is given by SAR, specific absorption rate. And you can break this wording down to this. It's specific to the body part and the tissue. Again, it's what's absorbed, the amount of RF absorbed into the body or the tissue at the rate of the RF exposure and absorption. It is in units of watts per kilogram. So we're going to apply RF power into our patient. The patient is going to dissipate that energy by cooling. And quite simply, if the input is greater than the output, then heating occurs. And one other way to look at it, power in minus power out, is SAR. The SAR is estimated per series based on the RF power that's used and certain patient-related factors that are assumed by the vendor's algorithms. There's no industry standard as to how the vendors would estimate SAR, and all of the vendors are going to use their own proprietary algorithms to estimate SAR. Now, the FDA provides guidelines. Manufacturers can use those guidelines or their own, but they must show that they are safe. The IEC provides standards, and the manufacturers follow these IEC standards. The IEC standards break the RF power deposition into operating modes. The two clinical operating modes, which we can operate in again clinically, are the normal operating mode and first level controlled mode. In the normal operating mode, the whole body SAR is to be less than or equal to 2 watts per kilogram, and at this level, no physiologic stress is expected. In the first level mode, again, this is for whole body SAR, it can be greater than 2 watts per kilogram up to the maximum of 4 watts per kilogram. And at this level, physiologic stress is possible. For the head, both normal and first level are less than or equal to 3.2 watts per kilogram, and in general, no physiologic stress is expected. The patient's cooling is influenced by multiple factors. Most of these are environmental, and that is the bore temperature, the ambient temperature of the room, the relative humidity of the room, and the airflow rate. Now, many systems will actually deregulate the SAR or reduce SAR limits if the temperature increases above 24 degrees Celsius or 75 degrees Fahrenheit. The other two factors that influence cooling are patient-related or patient-dependent, and that is perspiration and blood flow. The following is taken from a paper or a article on MRIsafety.com. And in it, Dr. Frank Shellock states that various underlying health conditions may affect an individual's ability to tolerate a thermal challenge, and they include cardiovascular disease, hypertension, diabetes, fever, old age, and obesity, a small subset of your patient population, I'm sure. And in addition to this, medications that include diuretics, beta blockers, calcium blockers, amphetamines, and sedatives can also alter the thermoregulatory response to a heat load. Now, What can we do to manage or reduce SAR? Well, there are several parameters that affect SAR. The TR, based on the number of slices, the echo train length or turbo factor, depending on how your vendor expresses this, the echo spacing, and closely related, the receiver bandwidth, the flip angle for gradient echoes, or the refocusing angle in a spin echo or fast spin echo sequence. And then there are specific pulse sequences, some which tend to be higher SAR than others. For example, fast spin echo tends to be higher SAR than a conventional spin echo. Now, in order to manage SAR, there are several things that we need to keep in mind that we can do. Number one, we can scan in the normal operating mode as much as possible. Secondly, don't use the minimum TR for the maximum number of slices for long TR sequences. In other words, if, say, you're doing a sagittal T2 something or other, and the slices that you need are, let's say, 14 slices, and to get those 14 slices, the system will need a minimum TR of 3,000 milliseconds. Well, don't use 3,000 milliseconds in that situation. Use 3,500 or 3,600. Just go up a little bit. Don't pack the TR with the maximum number of slices. Again, all you've got to do is increase that TR a little bit, and that allows a small amount of time for cooling. Speaking of allowing time for cooling, pause between the sequences. Try not to run every sequence back to back to back. With modern systems today, as soon as one scan ends, the next scan begins. So giving just a few seconds between sequences will again allow a patient time to cool. And in that time, you can also check with the patient to see how they're doing. Also, don't wrap the patients in blankets, certainly not heated blankets. Remember, you're putting RF energy into the patient's going to need to cool to release that energy. And if you have them wrapped in a blanket, then they're not going to be able to cool. Along the same lines, make sure you have plenty of air moving through the bore. Most cylindrical bore magnets have a bore fan to move air through the magnet. Make sure that is happening, because this is a way that patients can cool. Another thing you can do is alternate between high and low SAR sequences. Instead of doing several high SAR sequences in a row, mix them up a little bit and alternate those sequences. And then you may also have vendor-specific options. Low SAR mode is just one that I can think of. There are other types of pulses, verse pulses, for example, on 3T systems that are more SAR-friendly. So look to use sequences or options that are more SAR-friendly. And above all, try to stay in that normal operating mode as much as possible. Well, that brings us to the end of this video and our SMRT Safety Video Podcast Series for MR Safety Week 2017. We hope you've taken this week and the opportunity to look at these video podcasts, evaluate your own operating procedures, policies, procedures, your methods, techniques, and adapt some of the things that we've spoken about to your particular practice and your particular facility so that you can improve safety for your patients as well as your staff. So once again, I want to thank you for taking the time to watch. We hope you found this information useful. Until next time, this is Bill Faulkner. Thanks again, and take care.